What is hematocrit? It is nothing more than a ratio of a whole. It is not a tangible thing. It's not something you could touch and feel. You can't raise or lower hematocrit because it does not actually matter. You can change the ratio, which then changes the measurement of hematocrit.
Dilution.
It's nothing more than dilution, exactly. So I know we touched on this in a previous video, but being that this one's dedicated to the topic, I want to use the same analogy here. I actually have my cup of coffee because my head won't function otherwise. And when I make this coffee, I put a teaspoon of coffee in, and then I put X amount of water. The ratio of coffee to water, or ratio of coffee to total matter in the cup, is essentially just a ratio. And that could be measured as a percentage. And hematocrit, even though it's written out as a number, if you look to the right at the units, it's actually a percentage. So if I wanted to change the percentage or the ratio of coffee, I could do two things. First, I can add more coffee, which elevates the ratio, or I can reduce the amount of water, which elevates the ratio. So the same thing goes to hematocrit. Hematocrit is nothing more than the ratio of hemoglobin in the total blood. We can affect change in one of two ways. We can change the amount of hemoglobin in the blood, which is carried by red blood cells, so we can increase or reduce the amount of red blood cells, or we can change the volume of plasma, which is the clear fluid or yellowish fluid in the blood that transports nutrients. And we can increase plasma with increased hydration, and we can decrease plasma when we are dehydrated. So your hematocrit is so transient that it'll literally change several times a day. In fact, it changes all the time throughout the day. So if you wake up and you're going in for labs and you're fasted, fasting means do not eat, do not spike your insulin, do not consume protein, carbs, or fats. It does not mean do not drink water. Because when you go in and you're fasted and you're dehydrated, not only is it harder to draw your blood because it doesn't flow properly, but your hematocrit is going to be falsely elevated because the amount of plasma in your serum is going to be reduced. So if you drink a couple of water bottles prior to go in, let's say 2 of these, which is about 36 ounces of fluid, 1 to 2 hours before your blood draw, your plasma volume will be sufficient, and then your hematocrit is not going to be falsely elevated. So I think a lot of guys get into trouble when they go for their labs because they're fasting and they think don't drink water, and as a result, they have falsely high hematocrit. And it's often evident when guys post their labs, and we'll often say, well, you're dehydrated. And they say, how do you know? Well, your hemoglobin is at 17 and your hematocrit's at 54. That just doesn't align physiologically. This is a state of abnormality, which is temporary, caused by an external variable, which you obviously did not drink. So if I saw a 54 hematocrit and the guy was well hydrated and this was done properly, I would expect his hemoglobin to be probably 19 and a half. So when we see 16, 5, 17, and yet hematocrits in the mid 50s, we know the guy's dehydrated. So don't put so much weight on hematocrit. Obviously, there's a lot more to this, which we'll get into, but Jordan, if you want to add anything to that.
Yeah, I mean, in simplistic terms, I think that's the easiest way to think about it, is it's simply dilution. And even the hemoglobin can change with that. I mean, you get hemo concentration in dehydration as well, because there is a link between hemoglobin and hematocrit. Obviously, hemoglobin is attached to the red blood cells. So there is often a correlation between those. I mean, we used to just use a general rule of multiply hemoglobin times 3 to get an idea of what the hematocrit would be. And it's fairly close. So there is correlation with that. But yeah, I mean, the hematocrit, when guys look at their lab work, you can also tell they're dehydrated if you look at like BU and creatinine ratio often, will be elevated, in these guys. And so that can also show some dehydration. And you go, well, you may need to be better hydrated next time. I mean, personal example, my hematocrit recently, 8 weeks ago when I was dehydrated, was 58. Like first thing in the morning, lab draw, hadn't had anything. And I went back and got it done a few weeks later. I was hydrated up, felt better, just normal conditions. And my hematocrit was 53. So huge difference, especially for other doctors who might look at that and freak out. So, and
why are people on testosterone replacement therapy always are so worried about it? Always asking on forums about the hematocrit. What's it about that number they are worried about?
I think a lot of it is regurgitation from forums. Guys will just hop on, they'll read it. You'll get all these guys that come in and just simply reply, oh, your hematocrit. Oh, I'm out of breath, your hematocrit's high. I'm feeling lightheaded. Check your hematocrit. Go donate blood. I mean, it's constant regurgitation, and then it leads to an exponential effect of more misinformation, and they don't quite understand.
It's actually another nocebo effect is what it is. It's the same with estrogen that we always see. They start getting fixated on a number, and they think that's what's causing a symptom. And doctors have not done any justice to this either, because they associate high hematocrit with disease processes based on association studies of already sick people who had that high hematocrit for a physiologic reason. We as doctors in this country, especially, we always, in a lot of ways, we put the cart before the horse. So we'll see a response to something and think that's what's causing something, when it's the opposite. The body's pretty smart and responds in ways that it should. And then we look at that. It'd be like blaming an elevated white blood cell count for the inflammation, when it's like the inflammation is there for an underlying reason and your body's trying to heal itself. Like, find out what that is, and then the rest goes away. But we just constantly go, oh, we got to give you corticosteroids because your inflammation is going through the roof. It's like, you need to let your body actually heal. And it's the same thing with a lot of these studies on hematocrit. A lot of them too come from, there's a polycythemia vera, which is a blood cancer essentially, which causes elevation of all the blood lines, not just red blood cells. And that is linked to higher vascular complications because the platelets are also elevated. I'm sure a lot of clotting factors are affected as well. I'm not an expert in polycythemia, but when doctors call secondary erythrocytosis polycythemia, they're literally just changing language. Poly is multiple, polycythemia, multiple cells, like no brainer, right? But nobody even questions it. And they just say, oh, you got polycythemia from your testosterone. No, you don't. You have secondary erythrocytosis. And we see that. And I know people don't like talking about the high elevation stuff, but it's the same thing. The body is accommodated when you're at higher elevations. Those people will walk around with hematocrits often in the upper 50s. They're not symptomatic. Their body has adjusted to that. They're not dropping dead of blood clots. They're not being told to go donate blood every month or 2 months. So a lot of it's just, like Gil was saying, it's myth repeated often enough that it becomes truth. And it's guys looking for reasons for their symptoms. And most of these guys, a lot of them I'll see, they're having these symptoms because they've already been donating and they think that they're supposed to keep donating because their hematocrit's a certain number, and they've crashed their ferritin. And when you just look up the symptoms of low ferritin and you're like, dude, go check your ferritin. And it's like 10. And you're like, there's your problem. I mean, probably one of them. So anyway, that's my spiel.
Well, I think one thing is important to know, and I don't want to go too deep into how it works because I don't want to overcomplicate the issue, but people have to understand how blood is formed in order to understand how to control it. Because the first question we always get in the groups is, well, if my hemoglobin's X, my hematocrit's Y, what do I do about it? I mean, I don't want to come off therapy. How do I control it? So you have to first understand what forms blood. So the process of blood formation is called hematopoiesis, and it's just a fancy Greek word. Hemato means blood, poiesis means to synthesize or to make, which means the formation of blood. And this occurs in your bones, specifically in the epiphysis, which is the ends of the bone. The long shaft or the medullary cavity in adults tends to be less effective in this process because it fills with yellow bone marrow, which is mostly fats, but the red bone marrow continues to stay in the tips of the bone, in the spongy tissue, and this is responsible for the process of producing blood in general. And there are two major classes of blood, but myeloids are the classes that are, for this topic, important, and those are going to be the ones responsible for erythrocytes, which is a fancy word for red blood cells. So red blood cells essentially carry hemoglobin. There's something very unique about red blood cells. First is the lifespan, and secondly is their shape. They're one of the only blood cell, or the only cells in your body that do not contain a nucleus. There's no nucleus or ribosomes in red blood cells. Now, ribosomes is what's responsible for protein synthesis. All cells are responsible for protein synthesis, which is regeneration. Not only can they produce protein for export outside of the cell membrane into other tissues, but they also have organelles which form various protein functions in order to self-repair themselves. Because there's no nucleus and there's no ribosomes in red blood cells, they cannot self-repair. And because of that, they live on average 120 days in your body. The one thing they do carry is a protein called hemoglobin. And the shape of the red blood cell is very thin and narrow in the center, and they're kind of a little fatter on the outside, and that's where most of the hemoglobin is contained. The reason is so that they're pliable and they're able to squeeze into various different capillaries. The problem is that when they go through the heart chambers and they go through all these little bending and flexing, and then you combine with that the osmotic pressure from fluid where they have to expand and contract, over time they get damaged. And then your liver and your spleen are responsible for clearing those out. What they do is they recycle the ingredients that make up the hemoglobin, which is primarily, it's a protein, so it's primarily amino acids. You have heme and you have iron. Okay, you also have cobalamin, which is in simple terms known as B12, and you have folate or folic acid, which is choline. So essentially 3 ingredients that you need to be conscious of for the formation of red blood cells is choline, cobalamin or B12, and iron. So if you consume all 3, you're going to have a bigger opportunity to produce red blood cells. And if you're deficient in any of these areas, you can lead to anemia in the extreme end of the low, but you could also inhibit red blood cell production. I know a lot of guys on TRT tend to supplement with B12 supplements or B complexes, or even I've seen a lot of clinics that prescribe HCG infused with methylcobalamin, which is B12. Now you're taking a guy who just started an androgen therapy, which is notorious for elevating red blood cell production, and out of the gate, you're not only starting him with HCG, but you're starting him on B12. And then you're wondering why his erythrocytes are spiking up. So again, if you're not deficient in B12, don't just take it because someone sold it to you and told you, oh, it'll give you energy. You are going to produce more red blood as a result. And I'll let Jordan touch on the, potential risks from a medical perspective about what happens with blood viscosity. But the last thing that I think we'll go back to later, which people have to understand, is another very important hormone outside of androgens that is primarily responsible for red blood cell production, and that is called erythropoietin. And this is made by your kidneys. And this is something that for short is known as EPO. And if anyone remembers the Lance Armstrong scandal, this was the synthetic version of EPO that he was using to elevate his endurance. So we can get back into the hormone aspect later. But Jordan, if you want to maybe discuss some of that stuff as far as what happens with viscosity.
Yeah, and I'm not an expert in viscosity of blood at all. There's a lot of papers when you start looking into this, and it's a lot of physics, engineering type stuff where you look at shear stress and all these things. But I think that's the bigger fear people have when they always think that increased hematocrit just increases the quote unquote thickness of the blood, and it puts you at higher risk for clotting because they think the blood's just not moving as quickly. And it makes sense on the surface, but there's more to blood viscosity than just that. So what I've seen, there's no studies in humans directly with TRT and blood viscosity. There's just not. There were 2 studies I found in rats or mice that were very interesting, both showing a transient increase in viscosity and then a compensatory mechanism with increased nitric oxide that basically negated any bad effects. And so that the overall viscosity or shear stress, maybe both, did not actually change. And so I thought that was really interesting that, our bodies can compensate for this by just making more nitric oxide. In fact, we always hear that increased hematocrit increases blood pressure. The studies I've seen show that that's actually often not the case. You actually your blood pressure will lower, likely from the nitric oxide compensating. I need to find the papers. There were a couple of good trauma papers because they were looking at this more from a blood infusion standpoint, blood transfusion standpoint during traumas. And it kind of blew out of the water a lot of these theories on hematocrit and what we think versus what the reality was, what they were seeing. I'll try to find those and we can post links under here. But it's just now being looked into. I saw a paper recently, just this year, 2019, from a hematology journal, asking maybe we should start questioning erythrocytosis again in healthy patients versus what we're calling, erythrocytosis in sick people, because there are medical conditions of erythrocytosis that can be pathologic, but you can't lump all those together in the same group. And again, I mean, you kind of got to go back to common sense with this too, that you look at guys at high elevation, and yeah, that people are like, oh, well, they're acclimated to it. Well, yeah, but so do we. We get acclimated to a higher hematocrit on testosterone. Is there maybe an increased risk in the first 6 months when you're on it if you already have underlying medical issues? Maybe. I don't know. I think that'd be something that would be a great study to do. But overall, we know that TRT does not cause increased risk of thromboembolism. So there's just a lot of speculation that needs to be put to rest, but that's not going to happen until people do studies, and they have to be interventional studies, not on humans, on TRT. A lot of the guys we see already, if they come in already pre-TRT and their hematocrits are already in the mid-50s, they're probably smokers or COPD or sleep apnea, something like that going on. So I think there was people always want to blame EPO for, increased hematocrit, but there's more to that with testosterone. I think that it's not mainly working on the EPO system. And so there's other factors at play there as well, but that's something else that I have to relook at. I looked at this stuff months ago.
And it isn't. From all the literature I've read, testosterone in and of itself has an erythropoietic factor.
Yes.
90% of the erythropoiesis trigger occurs from EPO. So erythropoietin is released by the kidneys under a specific response, which is really important for guys to understand why and how this happens. There's an enzyme in the kidney called HIF1. It's hypoxia-induced factor 1. What this enzyme does is it either allows erythropoietin to be produced and released into the serum or not. And the way it's inhibited is simple. It has hydroxy groups attached to it, which is a hydrogen and an oxygen atom. And remember the oxygen, this is the key here. Hypoxia is a state of low oxygen. It is essentially suffocating a cell. So when the tissues in the body report low oxygenation levels, this hydroxyl group is not able to achieve sufficient oxygen in order to form the group. And therefore, the enzyme, which is inhibited by these hydroxys, is no longer inhibited, and it goes to work on secretion of erythropoietin. So it's a self-regulating mechanism. Low oxygen saturations elevate erythropoietin, make more red blood cells to compensate so we can carry more oxygen. Enough oxygen, hydroxy group is back on the HIF1, erythropoietin stops. And our people with renal failure or kidney diseases have an issue with erythropoietin, and they're more susceptible to anemia because they're not able to produce red blood cells. So one thing that people have to be very conscious of is, am I saturating sufficient levels of oxygen? And as Jordan alluded, there's a couple of reasons why you wouldn't. Maybe you live at a high elevation where there's thin air. So your body compensates by making more transport proteins, aka hemoglobin. Or maybe you have sleep apnea and you're just not breathing correctly. Maybe you're a smoker and it's a pulmonary respiratory issue and you're not going to saturate. What I do is I keep a pulse oximeter next to my bed. And the first thing I do when I wake up is I reach for it and I check my saturation levels, and right there is a 98. You want to be above 95 ideally. If you wake up and you're in the low 90s or high 80s, you have hypoxia. You're essentially suffocating in your sleep. So this is a good tool. I mean, look, we can hyperventilate and falsify the reading by just increasing oxygen, but if you're just laying there sleeping, in the morning you'll be a little lower than you are when you're active. But this is why I say 95. 95 is not a good level to be at when you're out and about during the day. People who are anemic tend to be lower. So a $15, $20 device from your pharmacy by your bed can tell you pretty much the quality of your sleep with regards to respiration. And this is going to have a much bigger effect because erythropoietin has a significant effect on your erythrocytosis compared to testosterone. This right here will have a much bigger impact on your level of hemoglobin and hematocrit than your androgen therapy.
But if you get both, then it's obviously going to affect it.
Compounding effect, absolutely.
But there's been some studies where they looked at, and they're conflicting, where they looked at EPO levels in guys on testosterone, and some showed an increased EPO level, and some showed no increased level. So again, you need more studies. You have to be able to reproduce things.
Again, it's an association. It's probably unrelated because testosterone.
There's other factors at play.
Mechanism. Yeah, it doesn't affect HIF1. It doesn't affect the kidneys in that regard. And it's two separate mechanisms.
Yeah.
You know, it's like saying, you know, guys on testosterone tend to wear blue shirts more often. I mean, just because that's just what you saw that day. It's totally association. I think, Stephen, if you had specific questions you wanted to cover, I think one thing people know is how to alleviate this.
Yeah, I wanted to ask you, are there any lifestyle prevention tips in order not to rise your hematocrit?
Absolutely. This is the most important part of the video. Now that you understand why this happens and how it happens, you want to know how to prevent it from happening, right? So in our clinic, what we do is we have something that we kind of nicknamed unofficially the erythropoiesis or erythrocytosis protocol. So when we take a look at labs and, you know, pass them on to a provider who's about to make a phone call to a patient, go over it, you know, we'll circle someone, we'll say, okay, you know, we're going to do an erythrocytosis protocol with this patient. We're going to explain to them why and how. Lifestyle changes are essential. First and foremost, diagnose if you have obstructive sleep apnea, if you snore heavily. A lot of guys who are just slightly bigger or heavier, if they have a large neck or a big chest, laying on your back is going to put a lot of pressure on your diaphragm. Remember, respiration can be voluntary or involuntary. You can control your breathing, but when you sleep, it's an involuntary movement. You don't have to think about it. So when you're sleeping and your body's trying to do its thing and you're designed to be a certain size and weight, and now you have a big neck and a lot of weight on your chest, whether it's muscle or fat, does not matter, by the way. If you're a big bodybuilder, you are just as susceptible as an obese person. Understand that it's like someone putting their foot on your chest, and when your body performs an involuntary action and it becomes inefficient, it's going to be diminished. The quality is going to be diminished. Your breaths are going to be shorter, and eventually it may lead to holding your breath and causing hypoxia. So sleeping on your side, you could put a pillow between your legs if it causes any hip pain. It also helps to keep you stable. Sleeping on your side tends to resolve this for a lot of guys who have this sleeping on their back issue. I know when I sleep on my back, I tend to snore a heck of a lot more. The only reason I know is because my wife tends to elbow me in the nose when it happens. So I attempt to sleep on my side because I don't want to, you know, wake up with a bloody nose. But definitely pay attention to that. Secondly, hydration. Everybody only drinks when they're thirsty. If you take a sports bottle, 32-ounce quart, fill it up, carry it with you, hold it in your hand, it's going to be annoying. You're going to remember to drink. Why? Because it's there. If I reach for water only when I remember to drink, I'm already dehydrated, and it's my body telling me go drink. Don't get to that level. Put down 4 or 5 quarts a day, and you're probably going to do a lot better on that end. Lastly, guys always see in the groups when I write LISS, L-I-S-S. What does this mean? LISS simply means, it's an acronym, low intensity steady state. When I say LISS cardio, it doesn't mean balls to the wall, cycling, running uphill, etc. This is low intensity steady state. You have an aerobic state and you have an anaerobic or glycolytic state. We want to maintain an aerobic state in order to improve oxygenation. So the aerobic state produces the most amount of aerobic energy out of a glucose molecule, and it's something that you could do for a long extended period of time without getting tired. If you ran a 400-meter sprint, this is an anaerobic activity. If you ran a marathon, it's an aerobic activity. So improving your aerobic conditioning or your VO2 max, the ability of your body to carry oxygen and transport it, by improving your cardiovascular system and your respiratory system, you're going to require less red blood cells to get the job done. If you're inhibiting the amount of oxygen you carry by being out of shape and unfit, you're going to have to make up for that gap with more elevation of red blood cells and therefore potential higher viscosity. So LISS cardio, literally keep your heart rate below the anaerobic threshold. A quick, easy way to find it if you really don't know where it is take 180 and subtract your age. So if you're 40 years old, keep it under 140. It's very easy if you're an experienced athlete to determine when you cross over from aerobic to anaerobic. You're going to feel the chest tightening within about 30 to 60 seconds. You're going to start gasping for air. You're going to feel the lactic acid specifically in your calves if you're running or cycling. And you're going to start feeling a burning sensation. What I always tell new athletes or guys that are just starting on, they don't have a heart rate monitor and they say, how do I know if I'm crossing over? Simple. Get on the phone with your buddy, and if they could tell that you're working out, you're probably anaerobic at that point. They should not be able to hear your breathing. All right. So just spend 30 to 40 minutes walking, brisk walk, nice slow bike. I mean, if you break a sweat, fine. If you don't, that's fine too. As long as you're moving, your heart rate's at 120, 125, keep it there for a half hour, you're going to saturate so much more oxygen the rest of the day because you're building efficiency in your vascular system. You're letting the heart kind of do its yoga and kind of stretch out and relax. Remember, guys, weightlifting, a lot of bodybuilders always say, I don't need to do cardio because when I weightlift, my heart's at 160 and that's my cardio for the day. No, your heart's contracting. And your systolic blood pressure is jumping up significantly when you're doing heavy weights, and your heart's trying to feed that, and it's like flexing really, really hard. And now what you want to do is you want to do the opposite. You want to let it stretch out, and you want to let those valves and the chambers kind of stay elastic and maintain. So the LISS is a real nice complement to the weights, and it's also going to help you maintain your blood cell level at a healthy state.
I have nothing to add to that. I think that's great. I think we probably need to start diving into more things too that might affect tissue oxygenation, any other medications that people take. It's something I need to look into, honestly, because any type of mitochondrial dysfunction, which I think is outside of insulin resistance, is another huge issue with chronic diseases that we see, even cancers, is lack of oxygen in the tissues. And there's got to be more to it, the things we're exposed to. And I mean, honestly, just like we talk about endocrine disrupting chemicals, there's things that disrupt our ability to efficiently perform, oxidative phosphorylation. That's what we're talking about here, instead of the glycolytic pathway. So it's something we need to look into more, just to have a complete picture to tell guys what to avoid and things like that. I don't know if metformin comes into play with this or not. I know there was some worry about mitochondrial respiration with metformin, and a lot of guys are taking metformin. I haven't looked that up, so it'd be something curious to see if that affects this at all as well. So.
Yeah, that would be interesting, since we know that most cellular respiration happens in the mitochondria.
Right.
If it was to be disrupted, that would be pretty catastrophic.
Yeah.
Just to add, the three main things that you need in order to form hemoglobin are amino acids, aka proteins, glucose, aka carbs, and phospholipids, aka fats. So if it sounds familiar, proteins, carbs, and fats are all essential for proper formation of cells.
Everything.
And if you're depleting yourself dramatically on one of those, then you also may have an imbalance in some of the body processes.
Yeah.
So can't state enough how some of these fat diets really do more damage than good.
And statins. I can't leave those out.
Yeah, absolutely. You're going to lower the base steroid hormone that's responsible for a majority of all hormone synthesis in the body, and then you're going to not understand why things don't work.
Yeah. Is there ever a certain number, sign, or symptom that people have to go donate blood when they're on TRT?
Oh, that's a good question. Gil, what have you seen? Because I mean, you'll see guys say a certain thing in the groups about how they feel, and they feel itchy skin or something like that.
I mean, guys will turn red and warm and itchy and whatnot. But here's the deal. This is the thing that I really hate, and it's unavoidable. And Jordan, I'm sure can have a lot to say on it, although I'm not sure he wants to. There is the science part of medicine, and there is the litigation part of medicine. A lot of the medicine that's practiced in America, and probably in most of the world these days, is really practiced by attorneys. Because at the end of the day, when someone ends up in court because someone filed a complaint for malpractice or anything that was not done properly, they're going to go by what's known as a standard of care. And the standards of care, unfortunately, in a lot of areas are not updated, and they're going based on old science. See, when we look at research, the gold standard, as we know, are random clinical trials. But random clinical trials tend to be ideal when they're 5 years or younger. When you look at stuff that's older, because medicine and science is constantly changing, well, science is not changing. Our understanding of science is evolving. Science has been here for millions of years, and it's not changing one bit. Okay, evolution doesn't happen that fast. But our ability to understand, decipher, and discover new things changes quite often. And then medication and practices change quite often. So the last 5 years of medicine and research is essentially considered the gold standard. What blows my mind is that so many standards of care are stuck in the 90s or the early part of the millennium. And then they're still considered standards. Estrogen is one perfect example. Testosterone in general, you look at the last 5 years of research of Dr. Morgenthaler and some of these other guys that have put out the stuff, and Jordan, I know it's a pet peeve of his, the whole prostate thing. I mean, and if you look at modern literature, it all tells us one thing, and yet the standards of care that are written in place are still based on old literature. So when you look at erythrocytosis as an underlying issue in practice, a lot of the litigation is going to come from this old philosophy. So a lot of providers are going to try to mitigate the risk of litigation, and they're going to tell a guy, oh, you hit 51, go donate blood. And they're going to chart that they're going to, look, we did the consultation, we checked it, this is what happened, this is what we had to do. And it's no different than estradiol. I'm pretty certain that a lot of guys are going to prescribe aromatase inhibitors out of fear that, God forbid, this guy gets skyno and I get sued, and they're going to point to all this old studies, associations, bodybuilders, et cetera, and they're going to say, you didn't protect him correctly. Right. So I think that people donate prematurely. A lot of it has to do with their providers not wanting the liability and say, look, I told him to donate when he hit 52. I wouldn't give him a refill if he didn't get a phlebotomy. Whether or not they believe it because they're misinformed, or whether or not they know better and they're just doing it for legal purposes, doesn't change the fact that it's not doing anyone a good service, because as Jordan alluded earlier, you're going to dilute ferritin. Look, we need blood. There's a reason we have it. Do I want to go and spill my blood every 2 months? Absolutely not. Can it be beneficial once in a while? Sure. Can it help other people? Absolutely. It's a noble cause. Do I want to be on this constant chronic schedule of donations? Absolutely not. And often it is done by attorneys practicing medicine, and this is the biggest pet peeve I have.
Same. Yep, absolutely. Like I say, with the prostate stuff, and what you're seeing is you're seeing still science it's all association studies, and scientists should know, they know when they're taught you can't, correlation is not causation, but yet these studies are pumped out regardless, and in the body of it they may say correlated with, but the headline of it, or when it's used in another paper as a reference, will just be stated as fact that it's causative, and that gets perpetuated on, and it's the same with erythrocytosis. In these association studies of people who are already very sick, who have obvious reasons that they should be having erythrocytosis. So of course their outcomes are going to be worse because they're sick people. It was the same with prostate cancer and testosterone, because they associated castration and regression of prostate cancer with, well, then testosterone must feed it. Well, that's not actually true. So, but there's still people that hold on to that, and they state it as fact. And I mean, there's still urologists telling guys that, oh, I can't give you testosterone, it'll cause prostate cancer, it'll feed prostate cancer. I'm sorry, any urologist that's been trained and come out of training in the last 10 years should not be telling that to people. So this is a pet peeve because we're seeing it today in public with all the COVID crap, and there's a trust the experts, trust the science. That is a meaningless statement. That's like saying trust a human, right? It's completely devoid of context. You actually have to look at what they're saying and go read it and go look at the papers. Was it a well-done study? Who funded it? What were the primary outcomes that they were looking at? I mean, so many things you have to look into. Science is so twisted if you actually look at it. It's so political. These people are paid, usually government funded. They have to toe a certain party line to get that funding. They're never going to question each other. Any scientific whistleblowers are always blacklisted and they're ostracized. People have no idea how twisted it actually is. So we thankfully do this for fun and for a living, but we're not trying to put out papers on it. But a lot of the good research is still there, that you just have to tease through it enough and start putting the general picture together. And that's what we've done with the AI stuff, and I was nervous at first because I used to think you had to block estrogen, block aromatization. And once we started doing it with enough guys and seeing that they feel better and their health markers have improved and all these things, and you start getting a picture and going, yeah, there's something to this, because the body is pretty freaking smart. When we start blocking entire enzymatic pathways, you're going to get in trouble. Okay. Same with 5-alpha reductase, same with, HMG-CoA with statins, any of this stuff. We do it because we can, because we're looking for a specific outcome that may be meaningless. And I think we actually hurt people more than we help people with a lot of the stuff we do. So same thing with telling somebody to donate blood once a month. I see guys that come to me that have been doing that, and I'm like, let's check your ferritin. And it's literally 10, 12. And they have all those symptoms of low ferritin. They were thinking this whole time it was high hematocrit symptoms. So it's just,
So is the fatigue.
yeah.
So is the lack of motivation.
Yeah,
So
restless legs, shortness of breath. I'm like, do you really think, I mean, a little bit of high hematocrit is going to cause you shortness of breath? Do cyclists see that when they use EPO? You think they use that to get a high hematocrit so they get shortness of breath?
I would have loved to seen some of the labs that Armstrong had during the Tour
Yeah,
de France days. I'd be surprised if he wasn't in the 60s,
yeah, absolutely.
riding uphill while talking on his Bluetooth while guys were walking their bikes.
Absolutely. And you see, there's a lot of correlation from bodybuilders because they're taking these grams of gear, their hematocrit goes up and they feel like crap and well, it must be my hematocrit that's causing me to be short of breath. It can't be that you're eating 5,000 calories a day, you just gained 30 pounds in 6 weeks and you can't breathe, you're not doing cardio and you're taking all these drugs. It couldn't be that. It's either got to be your estrogen or your hematocrit. Yep, let's blame it on that. It just drives me wild.
This brings me back. I don't know if you guys caught this, but I made a little joke about my good friend Bruce in the group yesterday regarding the HCG diet.
Oh.
And my correlation to that was that we were talking about HCG diet. I think it was about a year ago, and I said, well, don't you understand that the reason that the people are losing weight is because they're eating 500 calories a day? What does HCG have to do with this? You're starving yourself, you're malnourished, you're going to reduce mass. It doesn't make it healthy, it doesn't make it sustainable or keepable. So please explain to me where the mechanism of HCG comes into play. And I was just waiting for someone to say, well, it's anti-catabolic because of the testosterone boost. Not even remotely close. And you know what? You can be on any amount of androgen and high doses. If you're eating 500 calories, I don't care who you are, you're losing muscle.
You can be on zero androgens. Yeah.
There's a reason they yo-yo. I mean, it's nothing more than just selling people a fad diet with an expensive medication and, having them regain the weight and come back and do another 40-day run.
Yep.
So that's why I said, well, let's throw in a couple of more variables into the HCG diet and give those the credit. And, it's all association, but unless you can explain the specific mechanism and the purpose of why something needs to be involved and how it works, then just saying, well, it was there, and therefore this is flawed logic.
That is exactly right. And people need to take that and extrapolate that, what you just said, to all this other stuff going on even right now. Everything you hear, go read the papers and look at the logic that was used in the methodology and see if something doesn't add up, because tons of stuff right now, especially, and I keep saying that, but it's true, is based on association studies and petri dishes. Okay? People need to look at that. And it's the same thing with a lot of other science that we do. And we always harp on petri dish studies are relatively useless for clinical application. It can generate more studies to be done in vivo. There's so much that is done and medicine's made based simply on association studies done in petri dishes. When you take cells out of the body and start manipulating them, you've already screwed physiology. It's done. It's over. That's not how they work. They work for a reason in our body. So people really need to be careful when they start looking at in vitro studies and what was done, and they're adding chemicals and toxins to cells. That's already jacking.
Yeah, I mean, the minute you die a cell, you destroyed all actions.
That's right. Yeah. Oh, all this stuff. They're showing these electron microscope pictures of all this stuff. The minute they fix those for that, they're done.
Done.
Yeah.
No proteins are moving at that point. And you know what? You're eliminating the hormone process, all the receptor actions.
Everything.
If we could take a cell out of the body, put it in a petri dish, and have it perform the way it did perform in the body, we would have cloned humans 50 years ago.
Yes, absolutely. And people don't know this, and this is not conspiracy stuff. There were a couple microscopes that were made that have now been extinct, I guess, that could actually view living tissue as it was, without fixing it. And for some reason, those just got off in the field of quackery, and it's like,
yeah,
what?
Because that puts you that much closer to actually finding cures for diseases, and there's no profit in that.
That's right. No, that's absolutely true. I mean, it really is true. It's not a conspiracy. People can look that stuff up, and then it makes you start questioning a lot of the modern day medicine that we've been taught, for the last, especially 100 years.